All right, Tom, we're going to do the second little piece of this, and I got to wrap this up because it's getting late, and it's getting late for you. So the correlation of the coefficient of correlation is R. That's this guy here, correlation of coefficient. That's 0.4296. Our formula for the slope is m equals r times the standard deviation of y over the standard deviation of x. And that is, r is 0.4296, the coefficient of correlation. And they gave us those two standard deviations, which tells us the slope is around 113 for this equation. Then we get to say that, roughly speaking, if we thought of this as a linear equation, y equals mx plus b, we know m is around 113, and we can say that our linear equation is, roughly speaking, equal to y equals 113x plus b. Now we can take a data point, and our data point is going to be the two means. Our y, our SAT mean, is 1033, and our x, our GPA mean, is 3.2. We should remember that this whole thing, we have our SAT score on the y-axis, we have our GPA on the x-axis, because the suggestion is that our SAT score depends on our GPA. So that's the dependence. Our linear equation is looking like y equals 113x, that's our slope, plus b, which we don't know yet. And we can plug in our means, which we can use as a data point. Y equals 1033, x equals 3.2. We let y equal 1033. This is our slope, 113, we've already talked about. X is 3.2. We plug all that stuff in and we can solve for b. If you put that in your calculator, you'll find that b equals 671.4. Now we have this equation. Our SAT score is, roughly speaking, equal to a slope of 113 times our GPA plus our y-intercept of 671.4. So we have something that looks like this if we cared. This, where our y-intercept is 671.4, and the slope of this line is about 113. So for every one point increase in GPA, our SAT score goes up by 113 points. All right, I'm calling that question, I'm drawing to a conclusion, and I'll send that to you and I'll continue. All right, Tom.